Hello guys, previously we discussed about referring the voltage referred to the secondary and the current referred to the secondary, as well as the voltage referred to the primary, the current referred to the primary. So we derived some formulas, but now on this video we will be referring the reactance and the resistance from the primary to the secondary and from the secondary to the primary. So we will every referred component is the formula used is derived from the ratio of the transformer. So if you can write the ratio, and we represent the ratio as A equals to N1 over N2. These are the windings, primary windings and the secondary windings. V1 over V2, voltage on the primary side and the voltage on the secondary side. I2 over I1, current on the secondary side, current on the primary side. This giving you the ratio of the transformer. So every formula is derived from here. So if we take this part where V1 is equal to V2 equals to I2 divided by I1. Cross multiply, we will have I1 V1 equals to V2 I1 V2. So this is what we have, but now we want to refer R1 to the secondary side and R2 to the primary side. So this means we need to change V, one of the two, either V or I. In this case, let's say we change V. So we know from Ohm's law, V is equal to IR, right? So you substitute in the place of V, IR. So we get from the from the primary side, in the place of V, we substitute I1 R1 equals to, on the secondary side, we'll be substituting in the place of V, I2 R2, right? So if we multiply out, we will have I squared R1 I2 squared R2, right? So in this case now, if we want to refer R2 to the primary side. So what we're going to do, so what we'll say R2 prime will be equal to R1, right? On this equation, R2 prime will be equal to R1 on this equation. So basically what we have to do now, we will have to substitute R2 prime in the place of R1. So it's going to be I squared 1 times R2 prime equals to I2 squared R2, right? Because we want R2 prime, we're gonna divide by I1 squared, both sides, I1 squared. So I1 squared will cancel out. So we will have R2 prime equals to I2 squared divided by I1 squared multiplied by R2, right? So knowing that I2 divided by I1 is still the same thing over all squared divided by R2, still the same thing as this one. Sorry, R1. I2 divided by I1 is a ratio of the transformer. So the formula will be A squared R2. So if you want to take R2 to the primary side, this is what you do, right? This also applies, the formula also applies when you want to take x2, let's say x2 prime will be equal to A squared R2. You want to take it to the, sorry, here it's JX2. You want to take it to the primary side. It also works the same. Okay. So basically now you can transfer or you refer x r prime 2 and x prime 2, they are sitting in the primary. Due to the ratio, we were able to get the new R2 on the secondary, on the primary side. So both these are sitting on the primary side. So if I would draw now a circuit, it will be like this. So this will be R1 and this will be R2 prime, and this will be J1, this will be J2 prime. Okay. Yeah. So the equivalent circuit now will look like this. So this will be our R1, then this one will be R2 prime, JX1, JX2 prime, right? Here you add the resistance in series and the reactances in series, right? Okay. So this is let's call it RZ equivalent. So the total impedance, let's call it Z equivalent. So basically, why are you doing this? So if you're given values for the primary and also resistance and the reactive values, and you are not given anything from the for the secondary terms of voltage and current, you can calculate the total impedance of the transformer on the primary side. Then you calculate the current as well as you calculate the secondary voltage using the voltage on the primary. So basically here you can use KVL to calculate this voltage sitting across the primary winding, right? This voltage will be the total voltage drop, okay? The total voltage drop, sorry, the total voltage minus the voltage drop, and you get this voltage sitting here. Okay, so how would you, this will look like this: E1, this is E1 minus I1 times Z equivalent, so the total impedance. So this will give you the voltage sitting here, right? So this voltage sitting here, as we discussed on the previous video, we can calculate the voltage that's sitting here, right? We can calculate this voltage E2 just by knowing this voltage sitting here. So this formula gives us the voltage that's sitting here. So then what we can do, as we know, we can derive from the ratio, which is I1 V1 equals to V equals to I2 V2, and then using this we can have a formula to calculate what's sitting in here. So we want to refer V1 to the secondary. So what we will do, we'll say V1 prime will be equal to V2, right? So in the place of V2, we substitute V1 prime. So it's I1 V1 equals to I2 V1 prime divided by I2 both sides, I2, then here. So now what will happen, our V1 prime will be equal to, this is a reciprocal of our ratio I2 over I1 of our transformer ratio, right? So now this means it's going to be, this is 1 over A. Now we'll have V1 divided by A. So this says V1 prime is equal to E2, right? So if you calculate this voltage sitting here, you are able to calculate the voltage on the secondary side, right? You are able to calculate that voltage on the secondary side. So from there on the secondary side, then you can also calculate the current. So as well, if you look at from the previous, we had the current. When you refer I1 prime to the secondary side, it goes A times I1, right? So since you were given everything from on the primary side, you can calculate everything for the secondary side as well by just referring what you have on the primary side to the secondary side. So if you have the current on the primary side, you can use this formula to refer to the current, the primary current, to the secondary side of the transformer. So the I1 prime is equal to I2, right? Always remember this. So this is how you derive the formulas to refer the resistance, firstly, resistance from the primary side, from the secondary side to the primary side, and the reactance from the secondary side to the primary side. This is the formula you use. So if you want to refer resistance from the primary side to the secondary side, you will use the opposite of the equation, whereby when you are referring from the secondary to the primary. So it will go by this. So it's going to be R1 prime, taking it to the secondary side. We will have R1 divided by A squared. A is the ratio, right? And then JX1 prime was equal to JX1 divided by A squared, right? And the equivalent circuit for this one will be resistor 2, resistor 1 prime, reactance. Okay, so you will have R2, here you will have R1 prime, then you have jx2, then you have jx1 prime, right? So basically this is what you're going to have when you refer to the primary using these equations, right? Then you add a total impedance. Let's say a total impedance will be Z equiv. So Z equiv will be equals to R2 plus R1 prime, put the brackets, plus J into X2 plus X1 prime. So that will be your total impedance. And then from there, you can calculate the current, the total current flowing on the secondary side. Then as well, you can also refer that current to the primary side using the equations that we already spoke about. So if you have any questions regarding the transformer, please comment. If you like the video, please like the video. And if you would like to subscribe, then you can subscribe or ask any question. Thank you.